Hello, Algebra 1. Welcome back to class. I hope you guys had a great break. For today, you're going to take some notes on adding and subtracting polynomials. This is a new concept, and with that, we do need to start off with some vocabulary. The first thing I want to be able to define or help you define is the word monomial. Monomial has the root word mono. Mono means one. So a monomial is a number variable or product. It can have an exponent, it could have variables, and it could be an integer. In a nutshell, a monomial is one term. Here's some examples. Examples of monomials will be the number 8, all by itself. The number negative 2x, that's a product of negative 2 and x. 3x squared y. Okay, even though there's a number and two variables and a power, it's still only one term. It's a number, variable, or product. I can even have a fraction in there, like 1/2 of x squared. So that would be the definition of monomial. Go ahead and pause now if you need more time to copy it down. Otherwise, we'll proceed to a clean page. This is vocabulary continued for our notes today. You also need to know what it means to be the degree of a monomial. So the degree is the sum of the exponents of the variables of a monomial. So examples of this. I have 3x squared. That's a second degree, because there's only one variable and its power is 2. Let's see 3x squared y. Well, I see a power of an exponent of 2 for x and an exponent of 1 for y. Remember, when there's no exponent, it's 1. Add 2 and 1 together and that gives you a third degree monomial. We're not counting the whole number, we're just counting the powers, the exponents of the variables. If you need more time to continue copying down, go ahead and pause at this time. Otherwise, continue to the next page. So we're going to continue here. We are going to talk about what a polynomial is. A polynomial is a sum of monomials or a single monomial. Now, nomial means number or term, and poly means many. So polynomial means many numbers or many terms. So keep in mind it could be the sum of monomials or a single monomial. Here is a example, and let me change back to a pen. 4x to the third is a polynomial. It happens to be a monomial because there's only one term. Now we could have something such as x to the third minus 8. Okay, I see two monomials. X to the third is a monomial. Negative 8 is a monomial. We call that a binomial. Bi as in bicycle. Bicycle has two wheels. A binomial then has two numbers, two terms. Last but not least, I have another example, and it is 7x to the second minus 4x plus 6. How many terms do you see there? How many monomials makes that up? You'll count them out, and you see that it takes 3. And so we call that a trinomial. Tri meaning 3, nomial meaning terms or numbers. Oops. So go ahead and pause now if you need to continue copying that down. Otherwise, you may proceed with our notes. So continuing with our notes, we have adding polynomials. Essentially, when you add polynomials, all you need to do is combine like terms. And you'll see on tests, and you'll see in on your benchmark that they say there's two different ways to combine your like terms. You can do so vertically, or you can combine like terms horizontally. And you already know this from elementary school. Here's what I mean. An example of combining like terms, monomials, for example, we just said earlier that 8 is a polynomial. It's a single term. It's a monomial. And if I try to add it vertically to another monomial, okay, I just combine those like terms, and 8 plus 3 becomes 11. Horizontally, we just say, okay, well, I've got an 8, I got a 3, I now have a binomial because there's two terms there. I can combine those like terms and I still get 11. You can go ahead and pause now if you want to continue with the notes, if you want to continue writing the notes. Otherwise, you can continue by letting it play through. We're going to go ahead and do some adding. This is example number 1. Go ahead and copy down the problem and hit pause to try to solve it on your own. The problem here is 5x to the third minus 2x plus x squared plus 7. There's 4 terms in that polynomial, and 3x squared plus 7 minus 4x. There's 3 terms in that polynomial. We call that a trinomial. So again, go ahead and pause here to solve, try it on your own, and then hit play to see the answer. So to combine these like terms, all we need to do is literally find which terms go together. I have a 5x to the third, and I don't have any other 5x to the thirds. So I write that first. It's the one with the largest exponent. I'm going to go ahead and combine my next largest exponent. I see x squared, and I see 3x squared. I can combine both of those, and when I combine them, I get 3x squared plus 1x squared, which is 4x squared. Continuing along with our combining process here, I see I have 2x and a negative 4x, so I'm going to go ahead and combine those, and we end up with negative 2 plus negative 4, which is negative 6x. And then last but not least, you have your constants all by themselves. you've got, oops, you cannot see that. You've got 7 and 7. You add those together and you get 14. Undo. So there's the 14. Alright, let's go ahead and continue with example number 2. Go ahead and take a moment, please, to copy down the problem, hit pause to do so, and then hit play to see the solution. So I'm going to go ahead and solve this one using the vertical method. So I'm going to line up my like terms. My first one has a 2x plus x minus 5. My second one has an x squared, it has an x, and it has a 6. So kind of like we did with systems of equations. We had lined up our x's, our y's, and our constant. Here we're lining up our common terms, x squared, x with 1 power, and then just your constants. You add those together and you have 3x squared, you have 2x's, and you have positive 1. And there goes our answer. Go ahead and pause now to continue copying that down, otherwise the notes will proceed. So right now I'm going to have you guys do some subtracting. It's essentially the same thing. We still need to combine like terms. But we need to remember that we have the distributive property when we are subtracting. And here's what I mean by that. In example 1, I have 3x squared minus 5x plus 3, and I want to subtract 2x squared minus x minus 4. I want to remind you when you're solving a problem like this that you do need to distribute, that there is an invisible 1 out in front of your parentheses, and that negative 1 gets multiplied by everything inside the parentheses. You might remember, taste the rainbow. And when I do that, I end up with 3x squared minus 5x plus 3. I'm rewriting the problem. Negative 1 times negative 2x is negative 2x squared. Negative 1 times negative x is positive 1x. And negative 1 times negative 4 is positive 4. Now that I've distributed, all I need to do is proceed with my combining like terms like you did in the previous examples. So let's go and see what that looks like here. We have our 3x squared and our negative 2x squared. We combine those. This is using the horizontal method. That gives you just a single x squared. Moving along, I have negative 5x and a positive x. Let's combine those, and we have a negative 4x when we do. And last but not least, let's go ahead and combine our whole numbers, our positive 3 and our positive 4, and that gives us positive 7. Okay, go ahead and pause it if you need to continue copying that down, otherwise the notes will continue. Alright, Algebra 1 class, go ahead and copy down subtracting example number 2 up on the board, and pause the video to try it out. Hit play to see the solution. So looking at this problem, for the solution, I want to remind you again, when you're subtracting, there is an invisible 1 here, and we need to distribute. Again, taste the rainbow. When I rewrite my problem, I have negative 2x to the third plus 5x squared minus 4x plus 8. That becomes positive 2x to the third, a negative 3x, and a positive 4. All of those change because they're being multiplied by a negative. Then you take your handy dandy highlighter. I have negative 2x to the third. I have positive 2x to the third. They cancel each other out. There's nothing to write down. My next term is 5x squared, and there's nothing to add to it on this particular problem. So I'm just going to go ahead and write 5x squared. Has no like terms to combine to. Okay, Moving along the process, I have my negative 4x and a negative 3x. You combine those like terms, you get a negative 7x. And then last but not least, we want to combine our constants. Looks like I used yellow already. Let's use purple. So 8 and 4 become 12. And there goes our final answer. So tonight's homework assignment is out of your textbook. You're being assigned page number 571. And you're doing numbers 11 through 19. If there's still time in class right now, feel free to use the textbooks in the back of the classroom to start your homework assignment. And good luck. We'll see you when I see you.